Okay, in this video I want to go over some of the some changes I made to the thread form tools that I have out in the user resources section of the forum. And basically what I did is I went through these parts and I made some changes to in the equation editor in all the parameters. So that if you open up the equation editor and click on favorites, and that should sort everything up. I've got these all pre-selected as favorites. So what I did is I renamed some of them and added some features here. Like I included a threads per inch parameter that is now thrown into the equation for pitch that drives the helical feature for helical height and pitch on the helical boss feature. I also have the average minor diameter set up to work off of the minor diameter minimum and maximum values, and then of course the material thickness is parameterized here. So basically the Z1, ZZ2, ZZ3, and ZZ4 are kind of the driving parameters to make these tools. The rest of these are controlling feature sizes on the tool. So like tool diameter, that's going to be the outer diameter of this. I got it at 0.531 right now. There's a slot length and width parameter in here now, and I added that because on some tooling manufacturers they actually include a pre-punch on there for their tool that is basically like a keyway slot, and this slot then makes it easier for the tool to form the thread when that special tool is used. Then I've added the fillets inside and outside, so these fillets here that finish off the tool inside and outside based off of material thickness. And then I guess, let me see here, and that takes care of what's in the equation editor. And I've got them all pre-selected for favorites, so all you just got to do is click on the header for favorite and brings them all up into the top. So if you wanted to use these as a starting point for your own tools, then it's easy enough to come in here and key in some new parameters for material gauge and for threads per inch, and then that'll rebuild the tool for your particular size tool. Now when you use these in sheet metal, it's important that the pre-punch hole that you use, let me open up go back here and I'll edit the holes here. Now these holes, make sure that they do not get close to a bend region, otherwise the part will not be able to flatten. The other thing is that you can make these holes either the same size or slightly smaller than the tool size. So right now these holes are 1/2 inch, and when the Boolean is created, the parts will still join up just fine. So as you can see here now, the inner diameter, this is the size of the pre-punched hole, and then this line here is actually the edge of the tool. So when they're placed in here through the constraints, they'll you open this up, so you still have, I use fastener constraints to locate them. So it's basically just selecting the two edges, and then you might have to flip it to get to the right orientation, because you want these to punch inward so that when the screw is put in here and it draws down, it draws against the helix of the form. And one other thing that you want to do is on your pre-punch, add some axes to each one. So that's going to help you when you insert this part into another sheet metal component or mate it with another part. So like in this assembly, you can see that the constraints it's constraining the axis on the barrier to the to the face of the hole in this hat section, and that on both holes that gives you the coaxial condition for mating that this barrier onto the surface of this, as far as lining with the holes. And then there's also the coincident, of course, that gives you the face-to-face coincidence. So, as I said, I got most of the parameters for this thing, for these tools, off of the Engineer Edge website, and I used their parameters for thread on the type AB screw, using their minor diameter min and max values, and highlighted tools here, or threads. Screw sizes are the ones that I've got designed for both 16 gauge and 18 gauge material. So if you want to do something smaller, or go to a smaller gauge material like 22 or 20 gauge material, then using these as a basis for that would be easy enough to do. The other thing I'm going to do is that I'm back in the user forum. If you go to the resources, I'm going to be adding these to the section here. I'll be updating the files that are in there already, so there'll be an update information in the user forum resources section. I'm also going to include a couple of links, one to this Fabricator magazine article describing the use of a helix tool for fastener. And actually this one is kind of highlighting this tool made by, let me see, where's that company at? High Torque Engineering Limited. They have a unique system where they're actually having the forming tool, but they also apparently have a custom designed screw that utilizes the helix form a little bit better than a standard sheet metal screw. My experience is using these is just in using actually a metric sized sheet metal screw that was used in a product we developed to install and secure gland plates on an enclosure. The other link that I'll put out there is this one here to Mate Precision Technologies, and there's a nice video here showing how they're utilizing this to install their helix tool for creating a fastening feature for a customer that uses a display stand with several of these tools in them. So anyway, if you have any questions, leave comments below, or add some questions on the forum. And thanks for watching.